Okay, so some of you have completely zero idea what orchestration even is. Some people have a really pretty definite idea of what Temporal does and just want to bone up on the TypeScript SDK. I will say that I do not have time to go like into the whole what is Temporal and how does it work. We have other talks for that, so the best place to find out more about it, I guess, is our YouTube, as well as where we've done longer form intros, as well as the 3-hour workshop of the full TypeScript SDK, as well as our blog. I think it's this one, where we've talked a little bit about architecture, if that is the kind of thing that floats your boat. So the people who really like a rigorous system architecture stuff, definitely check this all out. But what we're going to do today is get familiar with the SDK APIs. What is Temporal? I'm just going to do a couple slides of intro. So Temporal is the open source runtime for managing distributed application state at scale. Notice we don't say workflow engine here, and we don't say orchestration, but you can use it for those purposes. This happens to be the central insight that we want to give people, that we are the sort of single central component that is stateful, that turns everything else stateless, which is a very nice property as you design your systems. Personally, the whole reason I'm here, the reason I am working on this, is that I think that the core loops of a lot of different companies are long running and tie together multiple services. Temporal was started originally at Uber as an open source project, where it runs over 300 use cases, everything from driver loyalty points to email marketing and messaging to a lot of the CI/CD stuff that powers the Uber backend and infrastructure. Checker, actually, we just had present at our meetup. Checker is a background check API that involves a lot of human-in-the-loop work, going to check criminal records and courthouse records and stuff like that from a single API call. And so you do need some system to code all this thing up and version and migrate it. And I really enjoy how they presented it at our recent meetup. I have yet to put the video up. Netflix uses us for CI/CD. They also have a very, I think they are our most watched talk there. So just go to temporal.io/Netflix if you're interested in that Netflix. So we tend to keep it straightforward, how Temporal uses Netflix, how Netflix uses Temporal, and so on and so forth. Coinbase uses workflows are the Slack messages coming through? Let me just kill the Slack, because I know it gives some people anxiety. People report that when the Slack ping comes up in my recordings, they're like, maybe get PTSD. So one thing that we also do for you as a part of our bread and butter is distributed transactions. And this is very useful for some of our users like Box and Coinbase, where you can think about the exchange of fiat currency, the deposit and withdrawal of different accounts as a distributed transaction that needs to be tied together or undone together. So you have to implement some concept of a saga pattern. And finally, Stripe exposes us as a workflow engine team to the rest of Stripe. One angle I really like about Temporal is that essentially the cost is paid by the first adopter within a company. Every other subsequent user within the company has a much easier time adopting Temporal, because the first user has already figured out the platform hosting and code integration points necessary for their own team. Again, another presentation here that is highly anticipated, Temporal.io/Stripe. You can find more about that. These talks tend to be pretty short, which I love. Okay, so I'm not here to sell you Temporal, you're already here. The main mental model, the two main mental models I want you to have. The first one is anytime you're doing anything long running and asynchronous, they tend to be built up as an ad hoc mix of either endpoints and queues and more queues and state machines and schedulers and all that. And there's not really that much discipline or rigor to it, mostly out of necessity, right? You're trying to ship something, a feature, while also implementing the infrastructure and the reliability code around it. Temporal gives you a framework essentially to organize all that code, whereas it just says your entry point, whatever that is. I've been recently told not to use your app because your app spans the whole thing. Fires off work into the central Temporal cloud black box or Temporal server black box, whether or not that it's hosted by you or hosted by us, and that farms out work to a fleet of Temporal workers that have those workflows and activities registered to execute those commands that you send out. So I just use a lot of jargon in there, and I don't expect you to always get it, but hopefully you get the rough idea that we're putting this in order, and we're giving you a system that has all these things kind of baked in by the out of the box, so that you as a developer or as an application developer aren't really responsible for that. That's a simple contract of Temporal. You use our SDKs, we give you all this kind of out of the box, and I really like that. Okay, cool. All right, the second mental model is going to come now, but we're going to look at some code because we love code. So this is the TypeScript SDK. We went for the minimal design possible. And that is a workflow function. This is kind of the core central concept of Temporal, which is just an async function. It takes inputs and optionally returns outputs. It has a name or type called hello workflow, and then implementation where you can do stuff in here. Here we're only doing string concatenation, which is super trivial, but this just goes to show this is the minimum requirement of a workflow. It just does, it takes inputs and does some stuff, but it has special constraints primarily the constraint is that everything in here must be deterministic. We mock out any calls to math.random. There's no calls to the file system or the web, because those can be non-deterministic. When you call them repeatedly, they would return different results based on what the external state of the system is. Everything here needs to be deterministic. So, okay, what good is a program that doesn't do any I/O? We have a system to do I/O, and that is by splitting out the external work to a different function called an activity. An activity runs inside of the standard Node.js context. So everything you can do in Node.js, you can do in activities. And the basic requirement here with activities is that they be idempotent. In other words, you run the same code repeatedly. If for example, you have a retry and the call fails, the internal implementation fails in some way, we can just run it again, and you would not be, your world will not be wrecked. So sometimes you do need to take care to introduce some kind of idempotency key. But that's the basic separation. Workflows organize the sequence of events within your orchestration system, and they call out to activities to execute, to do the actual work and get back results for you to work on the next thing. So I'll show you why. Like, this is a very, very long-winded way to try to do something that you could do in regular Node.js. What is the point of doing something like it? The basic premise, the very basic benefit that everyone gets when they move code onto Temporal is that they get a declarative system of timeouts and retries that is also durable. So I'll show you exactly what I mean by that, but I think this is very well thought out. So essentially when you proxy activities, which is essentially like from the deterministic environment calling out to the Node.js environment, where you can execute code, you can actually set your start to close. You can set a system of timeouts and their retry policies. So let me explain what timeouts are, because depending on your background, you may or may not have really thought about them as much. But it's actually not that hard once you have the right mental model for it. There are three states that you essentially have to take note of, which is one, when timeout is scheduled, meaning that we have decided to do something, decided to execute an activity, but it hasn't been started yet. Two, when the activity has been started by a worker, and three, when the activity is completed by a worker. So that means that the start to close timeout is the length of a single attempt, and the schedule to close timeout is the length of all the attempts, inclusive of retries. And those are the two main timeouts that you should know as someone trying out and adopting Temporal for the first time. There are two more advanced ones. I hate to call them advanced because you're going to need long-running activities fairly quickly, where you can heartbeat activities as you go along. In other words, like let's say you're processing a file upload and you're 60% done and your worker crashes. You would like to know about that sooner than your schedule to close or start to close timeout. So the heartbeat would be heartbeating every second or so, letting you know, like, hey, yeah, I'm still alive, still working on it. And if I stop, like, this is where I stopped. I stopped at 60% done. And when you fire me back up again, you can start again from the 60%. So I think that's a very useful feature for anything long running, particularly if you're working on large files. I don't know. Two more things I haven't. I'm going to show you in a bit, which is the sort of operational model. I've already teased it a little bit here. I kind of really want to emphasize that. So I've just shown you the workflow API. I've shown you the activity API. I've shown you timeouts and retries. And the two main things I haven't shown you yet are the clients and the workers. So we're going to go into the actual code to demo that for you. But primarily, I want you to understand that you as the application developer are responsible for your clients and workers calling and running and executing those workflows and activities. And the central platform team, or Temporal Cloud, which is us, is responsible for communicating with them and coordinating all the state and distributing that work to your worker fleet. So that's kind of the simplistic way I answer it. I also think it's important to understand that all of this communication is done via gRPC. Every single piece of work is assigned to a task queue, and you can have dynamically assigned task queues for routing of work to specific workers if your need gets there as well. So I've just thrown a lot at you. Does anyone have questions? Or I see Maxim is here. Max is our founder and made all this, if he has any corrections. Yes, no, it's fine. You don't have to ask anything, but I can go right into a code sample if no one has questions. I think people really tend to understand it once we see the real code. So the best way to get started in the TypeScript SDK, you go to temporal.io/ts. That's a short URL that redirects to the landing page on the docs. We have a little intro if you like video, but the best way is to open up these code samples, which are just all the examples of APIs that we've sort of put together for you to learn through real working code. I like to run Temporal in the browser because that means I don't tie up system resources for Docker Compose, which I really like. So I use Gitpod, which basically just opens up this sample repo in the browser, and I've already got it scripted, so it starts running the basic hello world functionality. So let's see if I oops. Okay, all right. So when you fire up Gitpod. When you fire up our basic hello world, you're going to be able to see two things. So one is, this is the hello world project. Let's actually try to zoom in to make sure you can see it. 4 million files you need to be aware of. Workflows.ts, this just contains the workflows. Nothing spectacular here except that it calls that proxy activities API, call out to an activity called greet, setting a start to close time on 1 minute. And then inside of workflow logic itself, it just calls that activity. The activity itself doesn't do anything particularly mind-blowing. It just does some string concatenation. The client is which you remember is the script that fires off a single workflow execution. Basically just says client.start. Which begins an asynchronous start and doesn't wait for the result of that workflow. It only waits for it at the end here when you call client handle.result, and gives it some arguments. So when I call the example workflow with the string, it's going to go ahead and apply that as an argument here, as the name argument, and that's going to get fed into the activity called greet, and greet is going to concatenate, interpolate that into hello string name. So that's basically what it does. One property that we really emphasize for this SDK is type safety. So for example, if I were to modify the surface area of this and just go time int, for whatever reason, it doesn't matter. This would also start raising an error. And so I have to give a lot of props to Roy's TypeScript wizardry to make this happen, because we want reliable systems and we want our tooling to help us. So this would only be happy. I think if I give this the wrong type, it would just error for me and just tell me that I expected a number. And that's just based on the type system. So that's as good as we can get out of TypeScript. But you can go pretty far with that. That's something that we all like very much. Okay. All right. The last thing, every single, sorry, I need to explain workers as well. So every workflow is assigned to a task queue and also has an assigned workflow ID. Here we've just generated a random ID, but in practice, you probably want to track it to like a customer ID, transaction ID, whatever that is. And the task queue needs to be reflected in the worker, where we'll say worker.create, and we'll have the path of the workflows that we're going to bundle, and then we'll have the path to activities, which we're going to import and run in Node.js, the Node.js environment, and it's going to listen on a task queue, which is going to be exactly matching. So let's enough talking, I think. Let's actually show you how this works. So I think the first thing I'm going to show you, I need to fire up the console. So let's see, 8088. Let's just go ahead and do that. Okay. I don't know. Can I just combine it like that? I can. Okay. All right. Let's. All right. So I have a pretty clean UI here, and I'm gonna just start off by kicking off a single workflow. Over here, that just means npm run workflow. That's just how we set up the script in npm in package.json, and that starts off that client without waiting, and now it's waiting for the work to be resolved. So Temporal server is running. What it does, it's receive that command to start a workflow, right? Oh, God damn it. Okay, this doesn't persist very well because Gitpod doesn't have a concept of local state. But anyway, so we have a workflow that's just started off, and it's running, but it's not completing, even though it should be a pretty simple transaction. Why is that? So we can dig into a little bit about the history, and you can see that, for example, we've kicked off a workflow execution. We scheduled a task to be picked up, but nothing is picking that task up. If I head over to the tutorial task queue, this is the old poller. This is the old worker. I don't have anything new onto that. So I actually need to run a worker on the separate window that is qualified, that is sort of able to start that off. Should probably have cleaned all this so as not to confuse you. So now I have a worker complete, and you can see what happens on the right, where I kicked off a workflow, and it waited until that worker was up. Once that worker was up, it was able to chew through that work that I gave it, and then it returned the result. I did not have to wait for this result. You could have got it separately as well. But that is the basic premise of Temporal, right? Like that you have the basic hello world, which is that everything is tracked in a database. For us right here, we're using Postgres, but you can also use Cassandra and MySQL. You have full observability over what we called everything with the exact IDs that you can go look up in the system to audit if anything went wrong. You have the inputs and outputs, as well as the full history of what happened when. So for example, here I can tell that it took me 1 minute and 6 seconds to fire up that worker between the time I started it and the time I actually spun it up. Okay, not very interesting. We just spent a long time doing Hello World. Let's actually modify this a little bit. And so I'd like to show the next trick, which is that we're going to make our activity always fail. So over here, instead of doing string interpolation, I'm just going to throw an error. This simulates a process that's very flaky. Oops. Right. Save it. The worker reloads with the new activity, and now I'm good to fire off that workflow again. So workflow. Fire it off. Okay, all right. Now it's started, and now it's not completing for a different reason. Now it says it's running. It's got 5 events, but now it's got this like weird pending activities thing. It's on attempt number 4 trying to execute this activity, and the failure, it's reporting that it's receiving an error called oops, which is exactly the error that we hard coded into the activity. Right, which is fantastic. This is exactly what we want. The next retry is in 1 second. So if I refresh this, normally this would just stay on the same page, but because Gitpod doesn't have any idea of browser state, we have to re-navigate every time. But now you can see that the attempts are slowing down. The time between attempts is increasing as per our exponential backoff policy. By default, the exponential backoff is uses a multiplier of 2. Which is exactly what I showed you in the previous slide, right? Like the initial interval is 1 second, second interval is 2 seconds, and so on and so forth, until a maximum interval, and you can cap it by a number of attempts as well, based on the API that you're trying to model in the real world, right? So this is really nice contracts. That's very well thought through to deliver all this functionality. Okay, so we're stuck here, which we keep trying to schedule that activity, and every few seconds or so, we're trying to retry that activity to see if it works now. Our activity worker has no idea that it's just hard coded an error. How do we fix it? I'm just going to go ahead and comment out the error. And that's going to reload the worker. And now that's going to complete that workflow as well in due time. When the next retry attempt happens, which I'm not sure. When's the next retry attempt? 30 seconds? 20 seconds. Okay, all right. Something I like to show as well actually is that I can bring the system down. So I'm gonna simulate the system crashing. So I just killed my worker, and I can also go ahead and kill temporal server as well. Yeah, I mean, I'm just gonna go ahead and do that. It takes a while to kill temporal server, but one thing I want to show you is that like these retries and timeouts are actually stateful, right? They are, if you were holding them in memory, they would not be robust to a crash in your system. So something that we really like to show is that like all of these are essentially different forms of timers, and they're all set on the temporal server side of things, so that even when temporal server itself is down, which I just killed it. So when I refresh this, there's nothing. The whole system's down. I just simulated total system outage. When I fire it back up again, it's going to pick up where it left off. It's going to check through its event history, look for timers that should have fired, and continue to attempt work on them. So now it's still going to keep running because I don't have a worker, but I'm going to bring my worker back up. So I'm recovering from that system failure, and now I should complete that job. If I understand, if I did it correctly. Did it finish? Let's see. Okay, it's waiting for the next workflow task. So
I have a quick question.
Yes, so now it's completed. Okay, so yeah, that's the fault tolerance. Yeah, go ahead.
What's the search like? Are you able to search based on like input values and things like that?
Okay. The straight answer is yes, with our advanced with our visibility functionality, if you set it that way. So yes, you can do search on arbitrary values. Here we only give you sort of temporal system values. In other words, we can give you basic search by workflow ID, workflow name, state of the workflow, and time. But if you want to search on arbitrary properties, you can upsert search attributes and define them at the start. So let's say your input is like you want to just say like my custom input is the string, and you want to be searched across all workflows. That would be the way to do it.
Got it. And another like stupid question, if I have the time.
Not at all.
Do we encode task dependencies within the workflow definition?
What is a task dependency?
Or sorry, like an activity dependency. Like I don't want this activity to run if this previous activity failed.
Yeah, sure. Yeah, I mean, there's all ways to do that. You can do a simple try catch. These are all standard types. If you can write TypeScript, you can model whatever you want.
Got it.
Right. Try catch or whatever. We also have a concept called cancellation scopes where you can programmatically cancel or move or tie various activities together as well. Okay.
I've got a question too.
Okay.
I don't know if it's the place because this is about TypeScript and my question is not about TypeScript, but it is about the fault tolerance of the system.
Yes.
And
Yes.
your demo you just simulated a full server down, etc. My question is, if I read correctly the documentation, the history microservice of Temporal is stateful. Does that work only if the exact same history service pops up, or can we just for example, in a stateless system, like for example in Kubernetes, can we just pop more instances of the history service or matching service, and it just goes up again? Or I mean,
yeah.
How does that work?
Yeah. The state is persisted in your backing database. everything is horizontally scalable. Every internal service of Temporal server is horizontally scalable.
Okay, but in your documentation it says that you cannot scale up or down the history service after the cluster creation. So maybe it's not the place. Maybe we can talk about that later at the end of the workshop.
Let me explain. You absolutely can scale out the history service. And again, all of this is using the Gossip protocol, so you can just add and remove any roles anytime, and it works out of the box. The thing you cannot change is number of shards. So practically, when you start this cluster, you say, I have, like say, 5,000 shards, and this number of 5,000 is set for life. Of the cluster. So if you set your cluster to 4 shards and add 50 history services, it's not going to help because there are only 4 shards. We ran clusters up to like tens of thousands of shards, like 36 or 1,000 or whatever. But having too many shards can also has a problem with just more memory utilization, more resource utilization of the database. So it's a kind of balancing act.
Okay, so basically it's not on the history service or matching service or anything. It's just the number of shards, the logical shards on the database, right?
Exactly. And it's again, it's not the physical shards
logical shards of, for example, workflows IDs or I don't know any plumbering in Temporal, but okay. Okay, got it.
Yeah. And they also, it's not only about for distribution between databases. For example, in Cassandra, they map to the partition keys, but it's also for parallelism. So right now in Temporal, single shard is fully synchronized. All updates for shard are synchronized. So it means that if you have very small number of shards, they will kind of workflows in the same shard will kind of affect each other. So you want to like as many shards as you can afford given your resource utilization, because there is certain overhead having more shards.
Okay. Okay. Thank you very much. I may contact you on other ways to help me on the scaling. Okay.
Definitely happy to help you in our Slack. So temporal.io/Slack. I have one DM question from Ula. Thanks, Maxime. Thanks for the input. I have one DM question from Ula, who's probably familiar with AWS step functions, right? Which is one of the other orchestration tools that you may have come across, and particularly in the serverless space. I'm not going to really criticize AWS step functions in public, but this is one of the reasons I left AWS to come here, which is I think we can do better. There are a number of limitations, primarily that this is kind of like a boxes and arrows DAG structure, which is basically you're limited to the programming constructs that they give you, and there's no way to test this, which is one of the reasons a major customer of ours has moved from AWS step functions to us, and version control and so on and so forth. But also to me, you have to reinvent the whole world of programming, which is functions, variables, branching, loops, modules, whatever. So there's that, which is kind of like the programming model argument. But then there's other arguments as well with regards to the system limits that they give you, with regards to how fast they respond in terms of processing tasks, the amount of payload that you can pass back and forth between them. Our users have run into all these issues with alternatives to us before coming to us. So I don't have the full list of the differences between our two platforms, but this is one of them. This is one of the major ones. I think another story which I really like, which I'm not sure what the story is for AWS step functions, which is that in this environment, we actually support encryption between client and server and worker. So in other words, if you have PII or payment data or health data, you can actually encrypt it on your side, so we never see it. We only see the state transitions and the commands to execute next, which is a very nice security feature for a lot of our biggest users. So keep that in mind. I don't have the full list, unfortunately. Okay, all right. So I'm gonna press on, but yeah, this is the basic hello world. Like you just moving existing code to Temporal, you get reliability out of the box, just kind of the way that I show you. And then you can start to get a little bit more adventurous with having done that work, right? Like what do you get by putting your system into this weird like workflow deterministic sandbox thing that we tell you to write it into? So you get access to a world of workflow APIs. Where you discover that is in the core API stock, and we have a bunch of workflow APIs that are listed for you to play around with. A lot of them to do with time, some of them to do with spawning child workflows, some of them to do with patching and versioning and running infinite workflows as well. But okay, so let's just use the basic, go to the basic demo example, which we always love to show off, which is that you can run an activity, sleep for 30 days, and then run another activity. Because as you understand, this is a durable timer, we don't care. This doesn't consume any system resources while it is running. So you can run a million of these simultaneously at once. And the way that you code starts to change as well. You start to model the end-to-end journey of a single user rather than saying, all right, we'll do this part, and then let's wait for a cron job to sweep through all users every 30 seconds or whatever, and then we'll proceed on in another function or something. This is a very nice way to organize code, and I really like it. So you can start to build constructs based on top of that. So for example, a very simple monthly billing workflow kind of looks like this, an infinite loop where you charge a certain amount and then you sleep until the next period. This sleep until is defined by you. So whatever API, we give you very primitive APIs. So here we can give you like number of seconds or a definite date. But if you have a way to interpret string dates, you can do that and write your own custom functions and share it with your coworkers to improve productivity, right? So you start having code sharing within Temporal as well. So I really like to show that off because I think that it's really worth it. As you start to build up competencies and start to improve your productivity of other developers. So, all right, we're not just for sleeping. Sleeping is obviously a nice party trick, but while you're doing long running work, how about responding to changes in the real world by being able to receive data, right? So we call that signals for getting data in and queries for getting data out. The way you define a signal is pretty straightforward. You define a signal and then you set a handler for it. And that when states update, the next bit of code that executes that starts to reflect the new value. So why do we show you all this? Why do we give you a bunch of primitives? Really, not because real world examples look like this, but more likely, especially for, I think, whoever was here to talk about building workflows, real world examples probably look more like this. There's a lot of little nuances to model. There's a lot less like trial periods. There's like, if this, then that, and then like get into this other step and then check these other conditions as well. Think about the tech stack and the amount of work that you would have to do to write something long running like this. And then realize that you can write all of it in a single function, top to bottom, covering the customer journey. So that is the promise, the overall promise. There's some problems with this code, by the way. I have yet to fix it. But that's the overall promise, right? That's the overall vision that you have all these new primitives to play with, and you can compose them to create something really special that spans the breadth of time, that is durable, and you don't have to, and you have a very sane way to handle retries and timeouts. So I really like showing that off. Any questions before I go into my final demo? No questions there. Okay, cool. I like to draw out a little bit as well. Like, we're not always about workflow APIs. We give you a lot of toys to play with once you move into the workflows and activities construct. But we also have a lot of APIs for security, for maintainability, for observability, stuff like that, which we think is very important for a production system. So we don't have time to cover any of that, unfortunately, and I need to learn more of that myself. But the maintainers here can help you as you explore and in your temporal journey. Basically, like most developers, you should start with the core concepts, move out into the prototyping your business use case of the APIs, and then start worrying about the production concerns as you put things into production. So finally, for the TypeScript users in the room, the number one framework is Next.js. So, and we had a couple of people in e-commerce. So I wanted to show off as well our e-commerce demo with Next.js, just to show you what it looks like in a semi-realistic situation. So what I have here is a Next.js project. You can clone this from the repo as well. And the only thing I do here is I'm running npm run dev, which has got a Next.js server running as well. Okay, so what that script does is it runs three things. It runs the Next.js front end, which calls to API routes that I've set up, which calls Temporal server. I have Temporal dev, which runs the worker as well. Actually it just runs Temporal. It just runs the Temporal workers as well. There's a compile step from TypeScript that I also have to write in there. Anyway, sorry for the ramble. Let me actually just go straight ahead and show you what I mean. So this example is meant to model one-click buy purchase, which is actually something that Maxim worked on at Amazon, in the sense that when you fire off a purchase, in a one-click buy context, you want to give the user some time to change their mind. So in other words, you're racing human action versus machine timeouts. There's I've sort of worked on the front end to give that example here. So a standard purchase that's just going to click and go through, but another different purchase I can click to cancel. Let's see what that actually looks like on the back end. So on the back end, you actually my front end buttons over here are calling. My front end buttons over here are calling Next.js API routes, and the Next.js API routes are sending signals in to my workers. So let's see my API routes. For example, here, if I'm canceling a purchase, I can signal cancel purchase, or I can actually just signal that the whole thing be canceled. There's also a workflow.cancel API that I should probably use more of. Either way, however way you want to handle it, there's pros and cons for each way of handling it. The workflow itself is defined in a sibling folder. So this is kind of like a monorepo context, and the workflow itself is pretty straightforward. It's setting a bunch of event listeners, or setting a bunch of signal handlers and query handlers, and then tracking purchase state and saying, okay, wait for the purchase state to be canceled, or a timeout of 5 seconds, whichever happens sooner. If the purchase state is canceled, we'll go ahead and process the cancellation. If the 5-second timeout happens, then we're going to check out the item. And that basically models the one-click purchase. And obviously, all this is fault tolerant. So that's kind of what you want as an e-commerce platform, that once you receive the order, you don't lose it in memory somehow. So yeah, that's the example. There's obviously a lot more examples here. Let's actually show you in what happens in the workflow history, which I really like to show off as well. So this is the final bit, I promise. God damn it, my computer is dying because of all the streaming. Okay, so the one-click, these are the two purchases that I did. The first purchase that went through without any cancellation, basically just started the timer, and then once the timer executed, it completed the rest of the purchase activities. And the second workflow that I fired off, I canceled midway. So over here, you can see that when I signaled the cancellation and what happened next as well. So yeah, it's a very basic example, but hopefully you can see that you can start modeling a lot of asynchronous processes like this. Humans versus machines, machines versus machines, activities versus other activities, whatever. Okay, I'm done. Questions? Yeah. Lauren, Roy,
Yeah.
anything? Oh, hi.
Yeah. When you need to patch workflows, I mean, update, the workflows. I've seen that there is some documentation on that, but is there some pitfalls or stuff that we should avoid doing, or are there some things we should know from the start that may leads us to places where we don't want to be, where even the patching system doesn't help us, or is there anything we should not do with the workflows?
Yeah, this is something that we're trying to figure out how to recommend as well to people. So Roy, he can help me out here if you want. But the main thing I want to say is like, first consider not patching. First consider just having a hard cutoff between the new workflow and the old workflow, and then just running different versions.
Okay, that works perfectly for short running workflows, but
exactly
okay, for long running workflows.
Yeah, for long running, sometimes you need to patch. Roy, it looks like you want to say something.
No.
I mean, I can. If there are any questions about what's a patch and why it's required, I guess I can say.
Yeah, the main conceptual understanding to have is like what requires patching and what doesn't, because a lot of times, as you saw me hotfix my code, if the code hasn't arrived to a certain point of execution, you can just hotfix what happens next, and then the workflow will not know any different. This is not really.
But you just don't know, right? And in production,
exactly.
you have a lot of workflows. They can
especially
be at any stage
of
the execution. Yeah. So basically, the rule of thumb is, always if you're changing some part of your code, you have to use the patch API, and basically that's the only safe way to ensure that the workflow executes. So basically what you do with the patch is that you say, okay, until a certain point of time, I want to execute the old code. And once my workflow is like no longer replaying when I'm actually processing new events, because I don't know if you've seen this part of like how the workflow is executed. Basically, like there's this whole history, right? So every time, let's say I start a new worker, what happens is that the whole like my code is replayed from the beginning using basically what happened using the events in history. So I'll get like a workflow started. I'll start the main function of the workflow will start running. It'll, let's say, in queue a timer. Then this timer is basically just a command that gets translated into an event in history. So when we're replaying, we don't actually schedule a new timer. We just check, okay, this is a timer that was created by the code previously. Instead of actually running the timer, there's just already like an event in history that says this timer was resolved. Then I can continue executing the code until I've reached the end of the history, and now I'm not in replay mode anymore, right? So this patched API says, okay, if this patch, I've seen this patch, it's a marker in history, right? So if I've seen this marker already, I'll execute the new code. Otherwise, the old code has to be executed in order for the program to reach the exact same state, right? It has to be deterministic. You have to be able to create the exact same program, basically.
Okay. So basically, if I'm in a loop, I'm in a while true loop, and I have this if in the loop. Each and every previous execution of the loop will go on the else.
Yeah.
And when I finally reach today, I mean, the current execution, I'll go on the if, right?
Yeah. So it's basically
okay.
You'll start executing the patched version once you see the patch in history. So it's from that point in history that your workflow will use the new branch.
So okay, yeah, that seems
So this API is basically check if there is a patch, and if we're not replaying, also record a patch in history. That's what it does.
Okay, pretty clear. And maybe it can be I don't know. Is it a good option? Okay, if I come back to what you said on we should probably try to not use the patch API. Would it be a good idea to, for example, use the patch API just to start the workflow as new and start in a new in the new workflow with the old state or something like that. For example, to handle that properly, to get rid of the patch as soon as possible.
Yeah, so you definitely, having all these patches definitely complicates the code, and also like you might be using dependencies. Let's say you have some dependency that like returns some number, and you decide how many activities to run based on the result of this external function, whatever that you're calling. You change this. You upgrade your dependencies. Now, instead of returning 4, it returns 5. You run 5 activities. Your workflow is now doing something that it didn't used to do, right? So it's very like brittle. The whole like upgrading workflows. It's a little hard to reason about like what exactly changes. So yeah, you always want to be extra safe. So like just change exactly what you want to change. And be careful if you're updating any like dependencies of your code. That would be like the rule of thumb. And if you can get to just basically like version the entire workflow, so we're gonna improve a lot on this experience. Like this year, we're putting a lot of efforts into improving it. But what a lot of companies do is they basically just, whenever they deploy a new version, they don't want to think about patching. So if you have like mostly short running workflows, or you don't have, like if you don't have a bug in your workflows, just leave your worker to finish all the processing, all the in-flight histories. But if you want to like deploy a new version, just deploy a new worker and using a new task queue. Let's say like the task queue would just have like a v1, v2 suffix. And then you know that everything is versioned, and you don't have to care about like versioning like specific parts of the code, just because of the complexity of that. So I think, yeah, the patching is like you should be used as a last resort. And currently it kind of sucks that you have to like deploy a new set of workers and use a different task queue in order to like basically version everything as a unit. But hopefully soon we'll improve this experience, at least for the TypeScript users.
We'll basically build that in.
Yeah, we'll probably build that in. So to your question is like, can I just use a patch to continue as new to a new workflow? It really depends on like which you can't just like put a patch in random, like in a random place. You might be able to use maybe, let's say, a signal that like you can even like just deploy a new version of your workflow, add a signal handler there that just calls continue as new. You can continue as new from a signal handler too. So just it would call continue as new with just basically transferring all the relevant state to a new workflow execution. That would be, I guess, a pretty safe way to do that. But in general, like try to avoid long-running workflows if you are just like complex long-running workflows, I would say. That was a very long answer. I hope I answered your question.
That was pretty clear. Okay. Okay, fine. I guess it's not that easy to avoid long-running workflow when you try to build a subscription system, but
yeah. So my recommendation in that, if that's what you're doing, is keep the long-running workflow really simple, and any complex logic code that you know that will change more often, put it in a child workflow, for example. Then the top level is very simple, right? And the child workflow, because if it's relatively short, you shouldn't have to worry about versioning it.
Okay, great.
Cool. Well, that's all the content that we had. We wanted to make it an approachable intro. Definitely the best way to learn it is just to try out the code samples. And then we'll be able to support you as you explore your journey. We're pretty active in the Temporal Slack as well as the forum as well. That's starting to ramp that up as a support venue. And there's a full workshop if you're very interested in learning the rest of the API features. There's a full workshop, I think like a 3-hour workshop that is at the end of the docs down here, 2-hour workshop where we talk a little bit more about this stuff that we went through. So I went fast because this is supposed to be a short intro, but here we are. Well, thanks so much for your time. And hopefully you have a better idea of where to use Temporal in your app. And we're happy to chat with you on Slack or email, whatever, if you need more info. Thanks, guys.